In this class or in this demo, we are supposed to know how to use it in or to implement it in the equation of motion and do some other examples. So first of all, let's talk about the free falling objects. There's something interesting about this natural phenomena. In other words, all free falling objects fall in the same acceleration, in which is called gravity acceleration. And there's a very simple experiment we can do just to prove that. If we make two different objects or two different mass with little change, like the first equation, the final velocity equal initial velocity. Now replace the acceleration with the gravity, and keep in your mind the g is always down, directed down, so it gets the negative sign, so it becomes minus g times d, the first equation. Second equation, now since we deal with vertical displacement, then we should use y or replace x with y, and then move on with other parameters and keep in your tall 50 meter, and there's an object or stone throw vertically up, reach to the maximum height, and then goes back to the ground. Keep in your mind the free fall, not necessarily the falling object down, it could also floor. So at the maximum height, v equal 0, and keep it that, remember this is max height. Okay, so and the acceleration is g as well, then it's easy to implement use the first equation, which is v equals v naught minus gt. V is 0, v naught is just 20, and but plus 20, not negative 20, because the initial maximum height would be maximum height would be the building height plus that one, which is 70.4 meter. Okay, now if the question asks us how long to, let's write it down, how long does the stone take to reach same vertical level? In other words, how long the stone does take to fly up and then go down to the same vertical level?
Now, this is one way that you can use to measure the acceleration due to gravity by using a falling object. And what we have here is probably a really, really tall retort stand, so probably one of the tallest ones that you can find at your school. On this retort stand, what we have are a couple of light gates, and we have basically the upper light gate, which basically is connected to a timer. This starts the stopwatch going, and then this bottom one here, as something falls through it, that then stops the timer. What we also have here is a mechanism to release something. And what we have here is an electromagnet. So this electromagnet, what we can do, we can use this to release something. And often they talk about having a ball that drops and falls through, but actually sometimes it might be better to use a cube of metal or a rectangular piece of metal. So this is going to be my falling object. Now this falling object should be kept at a constant height above the top light gate. So maybe this distance is x. And it doesn't really matter what it is as long as that is a constant distance. What we can then do is think about the distance from this light gate to this light gate, which in this case I'm going to label S. And when the electromagnet is turned off, this piece of iron or steel, that then becomes detached from this. It falls and accelerates through the top light gate, starts the timer, and it kind of stops the timer when it passes through the bottom light gate. And underneath this, what you need is some kind of material to act as a bit of a pad to cushion this object here so it doesn't damage the desk or doesn't damage the object. So in terms of the theory, what do we think about? Well, we can think about our Suvat equations. And what we can say is that S is equal to ut plus a half at squared, where effectively S is just this distance here. By the time this object meets the top light gate, it's travelling at a velocity of u, its initial velocity. We can measure the time between the light gates and we can use that to find the acceleration. So what we can do is we can basically do a few things of rearranging. So if I multiply both sides by 2, we can say that 2s is equal to ut plus at squared. And then if I divide both sides by t, I can say that 2s divided by t is equal to u plus at. And the key thing here is that this, that should be 2s up here, 2ut, and that should be 2u. Okay, so 2s over t equals 2u plus at. We can then use this here along some information that we get from here to plot a graph. And on the graph, what we can do is we can plot 2s over t on the y-axis, and on the x-axis what we can do is we can plot time. Now what that means is you can basically set this up and you can alter your value of s. So as you change s, going down to maybe sort of 25 centimetres, so there's a bit of a distance between the two light gates, you can basically increase it by 10 centimetre intervals, and you can have a load of values for s, that gives you loads of values for t. You can take the mean of many repeats, and then you can have a table of 2s over t and a value of t. What you should then find is that you have a relationship that looks a bit like this. And the reason for that is on the y-axis we have 2s over t, so this is my y term. Remember y equals mx plus c. I've plotted t on the x-axis. So what that means then is that the y-intercept over here should be equal to 2u. And that means then the gradient is going to be equal to the acceleration. And that's just a summary of using this method here to find out the acceleration due to gravity of an object falling between a couple of light gates. Hopefully that makes sense. In terms of safety aspects, well, I guess you've got electromagnets, so you want to make sure that you've got, you don't get electrocuted, and also that you cushion the bottom of this to stop that kind of hitting anything. And again, because you've got a very tall retort stand with lots of things on it, it's always worth clamping this onto the bench using a G-clamp or a couple of masses on it to stop it kind of wobbling. But hopefully that should all make sense. Good luck with your practical.